Hi everyone, welcome to another nightly TidalCycles video. This time we're going to talk a little bit more about using monads and defining functions and things like that. So one of the things I want to do is probably going to be another brief video. I want to test out my understanding of something, which is that. So the way two patterns combine when you add them, so the way two patterns combine when you add them, I think we can actually, the plus operator here has been kind of defined to make this work like that. But I think it should be possible to do something like this, which is adder 1, P1, P2. And then what we're doing here is, so P1, P2 are patterns, which means that if we're in the pattern monad, you should be able to take data out of them. Then we should be able to see something like x1 plus x2. Okay. So that type checks. And let's see. Okay, so let's copy and paste up here. Okay. So now if we say adder of the same patterns, see what happens. Okay, now let's check and see how this works. So here at 0 we have 5. 1/4 we have 7. 1/3 we have 10. 1/2 we have 11. 2/3 we have 13. 3/4 we have 15. And I think yes, okay, yes, it is actually the exact same thing. Okay, so what I would say is that this gives you a nice kind of rule of thumb, which is that if you have some intuition for how patterns combine, if you take structure from both the left and the right, then you can kind of assume that that's what it's going to do as you do these binding operations. So let's see if we can come up with something off the top of our heads that is, I don't know, does something weird and fascinating. So let's say, I don't know what, let's consider a pattern of samples. Yeah, actually let's do that. Okay. Let's see. I'm trying to think of how I want to do this. Let's do something like let's take a set of samples to strings and then a pattern of numbers, and then let's combine that together. And I don't know, this might be entirely zany. Might be fun. Let's see. Let's call it doink. I don't even know. And so let me see. Let's say sample pattern and number pattern. And what we want this to do is return a pattern of strings. So instead, let's do something like this. So this should be nice and simple. Okay. So what we're doing here is we're combining them like that, like we were showing. And then what we're doing is that we're attaching the that won't work. What we need to have. Yes, that should work. Okay. Okay. So if we look at the type of doink, it's a super general type, which is it takes basically a monad of strings. The list card is just string. In fact, here it's okay. So it takes monad of strings, a monad of anything you can show, and then combines it into a monad of strings. Okay. If we use, and this is a generic operation. Now, what should happen is that we say doink of oh. I see. Okay, we seem to be running into some. Okay. Okay. To explain the problem, it was just having some trouble, how I talked about type inference last time, right? This was having some actual trouble inferring the type. Can even look at it. The problem it was having was so the problem is that it was having trouble taking the list of numbers and actually knowing to turn that into a pattern. which I'm a little surprised by, but it's fine. But you can hear and now you can hear it. It's like combine them one to one. Okay, so let's do something else here. So yeah, that all kind of works the way you would expect. So I think for tomorrow I'm going to try and prepare some functions in advance rather than trying to think of them live, which I'm having sort of limited success with at the moment. And then and then we just try making music with weird things of this ilk, different combinators, seeing what's what, seeing if we can do just, strange things. And so, yeah, well, that'll be tomorrow's video. And until then, take care.